Hello students, let us begin with the first session in which we'll be discussing 10 problems in the physics section that came in AIEEE 2012 paper. Now let us look at the first problem. A wooden wheel of radius r is made of two semicircular parts as shown in the figure. The two parts are held together by a ring made of a metal strip of cross-sectional area S and total length L. L is slightly less than 2 pi r, that is the perimeter of the wheel. To fit the ring on the wheel, it is heated so that its temperature rises by delta T, and because of the increase in the length, it just steps over the wheel. As it is again allowed to cool down to surrounding temperature, it presses the semicircular parts together. If the coefficient of linear expansion of the metal is alpha and its Young modulus is y, the force that one part of the wheel applies on the other part is. Okay, now let us try to understand the situation. We have these two semicircular parts of the wheel. Okay, and as you heat up the metallic ring so that due to the increase in the length, due to the application of heat, it just steps over the semicircular parts. Okay, and when it is allowed to cool down, it would again try to regain its original length, but that is not allowed because now the semicircular parts is restricting its regain, as a result of which a tension T would be developed across the entire length of the metallic ring. Okay, now due to the tension T, there will be some stress sigma along the length of the ring, so that stress will be given by T by S. Okay, now when we heated the metallic ring, the increase in length is given by L alpha delta T, where delta T is the increase in temperature, alpha is thermal coefficient of linear expansion. So this is one aspect which we can write it as delta L by L equal to alpha delta T. Okay, now because it is not allowed to regain its original length, a mechanical stress is developed. That stress we have just calculated is equal to T by S, where S is the cross-sectional area, and a mechanical strain is also developed, which is delta L by L, that will be given by stress upon Young's modulus, that is T upon gamma S. Okay, now this mechanical strain is also equal to the thermal strain. Okay, so we can write this delta L by L as alpha delta T, that is equal to tension T upon Ys. So tension T is given by Ys alpha delta T, but we need to find out the force that is exerted by one circular ring on the other circular ring. Okay, sorry, wooden semicircular portion. So let us say they exert a force R on each other, that is normal reaction force. Okay, so if we make the FBD of only the top portion, it is under two mechanical tension, that is one acting here and one acting here, and a normal reaction force R here. Okay, so R, according to the FBD, normal reaction force R will be equal to 2 times tension. Okay, so R is equal to 2T, which is equal to 2Ys alpha delta T. This is the correct answer. Option D is the correct option.